Hello, everybody. Thank you for coming today. Uh, my name's Taylor, and 48 hours ago, I was in Southern California at the Swedish embassy that we have in Southern California. Um, we live in the future right now. Right now is the future. I started there 48 hours ago, and they packed a whole bunch of meat vehicles in a larger can with wings, and they squished us all together. And about 10 hours later, I was in Sweden or Copenhagen. Really, really cool. I watched Everything Everywhere All at Once, and that was a very good film. We live in the future. You can get lots of these packages to your doorstep in like, I don't know, 2 hours or something, some crazy stuff like that. Amazon Prime in the US. In fact, the future that we have right now is so good that they can afford to just send you a whole bunch of air, right? And it costs nothing to them. This is kind of becoming a meme. These like how much air they're sending with our goods. 10 books ends up being boxes. Even the bubble wrap has bubble wrap. Uh, it's crazy. They'll send you plastic for a CD that is CD-less. Sometimes they're a little bit misleading. They will sometimes they wanna beguile you. Uh, it just goes on and on. This one makes me angry. Sometimes it's people you love that are delivering this uselessness to you. Sometimes they're doing their best. Lots of plastic. Lots of yeah. Examples. I came adorned with eggs. I love eggs. Uh, this seems like a human problem, but nature also has this problem of not being able to pack things well. An atom is mostly nothing. Ooh, atom is mostly nothing. This is a football field, and the actual matter part of the atom is like a pea in that field. And this is not just physics. This is the mathematics underneath. This is how to optimally arrange 25 squares in a square. Take away one square, and that is how do you optimally do 24 squares in a square. What do you think 17 squares optimally looks like? 17. Oh God, that's optimum. Uh, Luckily, it's only 17. The rest of the just kidding. This is 19, but it's just the prime numbers. 18. Oh God. 11. 272. Um, this is kind of how materials work. You get these crystals and these sphere packing, and you pack them all together, and you get these really large effects over time, metallurgy, all these things, the shears at large scales. And we humans have been trying to tame these large scales. Yes, we team meat. We do great things sometimes when we really want to. When money's involved, you know. Look at this. Look how beautiful this is. The 2D, and you make it 3D, and you can pack a whole bunch of things in there. IKEA, oh, beautiful IKEA. They're irregular shapes, and you can pack them nicely. We've tamed nature, right? Eggs, back to eggs. You can do stuff like this. You can use cylinders to protect your chips. You can use octagons to ship your Oreo bits. You can use 2D manifolds in 3 space in order to protect your cups or lighting fixtures. And you can make 3D recycled materials, and you can smash it down small. And you can ship all of those very efficiently. Again, IKEA is quite well known for this type of thing. Made very big business out of it, good money. IKEA wasn't the first. 1850s, people were already thinking this way. This is the first known flat pack furniture. But Sweden really does do it best. This is 1944. Sweden is on its game. IKEA hits the market in 1953. One nice thing about this paradigm of flat pack furniture is you end up getting small and affordable. And when you have small and affordable, you also get stuff that's hackable. It's malleable because it's affordable and you've built it yourself. It shipped in a compact thing. You can do fun stuff with it. You can add casters to it. You can customize it for your family. You can do crazy stuff with it. I think we're just seeing the beginning of this. Take a single plywood sheet. People are doing amazing things with just a single plywood sheet. Look at all this, all these variations of furniture. What's super cool about just the idea of getting a CNC machine, computer controlled, and it just does the thing, is you don't even have to send the material. You can just send the bits. Another computer with wood that was grown on site can take care of it. The question is, how much air is in the bits? I'm not sure. I don't think anybody's really that sure. This is a chart of computer latency for a bunch of different machines. Kind of peaked, according to this chart, in 1983. How much air is in that CNC program and in the internet and the browser and all these things? I don't know. A lot of people feel that it's not like getting better, and Worth is accredited with this fun little phrase. It's funny, but it's also not. We're sending more bits than we are atoms. It's bananas, not actual bananas. We're sending a lot of stuff that might not be doing anything, and like it's actually doing stuff. Our industry is responsible for a lot of energy waste and carbon emissions. This is not good. This is 2012. We are above India. Imagine if we got like a 1% improvement on some of this air that we're sending. How many mouths we could feed, et cetera, et cetera. It's kind of a big deal. So we're here to talk about this big deal. Roughly what I'm going for. How much time do I have left? Oh, I'm good. I'm solid. Before I continue, I love words. Portmanteau is when you smash two words together. I like soft air. The air in soft words, soft air. It's unnecessary code. First, we have to figure out what unnecessary means in this context. Turns out Shannon, with his source coding theorem, found some upper limits on noisy. You're sending bits over a channel that doesn't quite do what you want, and you can send extra bits in order to correct the signal. It's kind of like what chips do. They add air, and the air is actually part of the package. The air is intended. So sometimes you get things like this. I personally like calling this error correction. Error. Okay. So the question, though, it gets a little bit more complicated when you start looking at like there's old MIDI, which is a piano roll, and you have sheet music, and this is a spectrogram of an MP3. What's unnecessary here? Is the MIDI the true one, and this is just a whole bunch of crud? You know, like, do we actually need all of the complexity of the MP3? A good place to start is you have these two strings. One is a bunch of repeating, and the other one is no perceivable pattern. And you can imagine that one way to compress it is just to use the smallest possible program. Another one's kind of incompressible. This is a Mandelbrot set, 23 megabytes as a bitmap. This particular picture, as a PNG, it is 1.6 megabytes. General compression works. But you can also imagine that the actual Mandelbrot set code is probably like bytes, kilobytes. So it's like, what are we getting at here? What's this core little concept in the middle? It's called Kolmogorov complexity. It's been beat to death. We've got some good ideas about what it is, and it is not helpful for solving the error problem that we're talking about for the most part, unfortunately. Yeah, it's kind of uncomputable. Thank you for my time. Just kidding. This is IP traffic over time. We're going petabytes, baby, petabytes per month. We're looking at exabytes, yottabytes. Everything's growing very fast. We have a lot of air left on the table. Carbon emissions over time, kind of the same thing, you know. We have to think like an economist. And how do economists think? They use natural experiments. What is that? It's a fancy phrase for studying stuff that already happened. Here's the Linux kernel over time. Lines of code. Lines of code's not a great metric, but it's what we have. We can maybe fudge some numbers. Mythical man. People have been talking about lines of code for a long time. One little proxy I have is that one year of dev time is about 20,000 lines of code. That's just a rough estimation when we're looking at different numbers. Nice to have something to convert back and forth to sanity check. Here's a sanity check, whole bunch of different operating systems that single people and many people have made, and it kind of roughly works, this 20,000 line metric. Anything interesting here? Dev centuries, dude. Oh, dev millennia, it's so big. Before I continue, I just want to remind you that zeros are easy to desensitize yourself to. 1,000 seconds is 16 minutes. 1 million seconds is 2 weeks. And 1 billion seconds is 32 years. Just remember that when you're like looking at these zeros. It's easy to forget. Okay. So the question is why is there so much bloat and air shipped in our software? I've heard a lot of theories, and I'm unconvinced by most of them. One is that like, oh, okay, well, corporations are not really incentivized to ship software that is lean and specific, and I don't know. I'm not convinced, and a lot of these type of things. So I'm going to kind of just go through some examples that I think are interesting to kind of, I don't know, maybe generate the right questions, because I'm not sure if we have the right questions yet. So the first 90%. They say that the first 90% of a project goes much faster than the second 90%. It's really, yeah, people I think underestimate the complexity of the first 90% and regularly overestimate the second 90% of a project. For instance, if you were to take a game from the N64, which is, if you look at these stats, much more powerful than a Game Boy Advance, you're like, okay, well, how much could you really port an N64 game to the advanced? And this guy did it. This guy's working on it. Whoa! it's Mario 64 running on a Game Boy Advance, and the guy's doing like really cool computer science stuff to make this work. It's like magic. You could follow his journey. He's just actively developing this thing. Highly recommend looking at. But that's games. Games are games. We want real stuff. This guy Casey filed a bug with Windows, and it was like, hey, it's slow. Let's make it faster. And after some drama, he came back and made his own terminal that's like 100 times faster in like two weekends, which is pretty dang good. And then there was some more drama, and he made another 10 times faster by changing a few lines, and still claims that there's more speed. And this whole thing ended up not great, and there's just a lot of egos involved. This is a very good case study in like how we're all people, folks. Reduce the ego, reduce the conflict, work together. Let's make good stuff. We are meat and the memes run us, like we, I don't know, just don't take things personally. All right, back on track. Browsers are very big. Browsers are now operating systems pretty much. And some people are trying to make this smaller, which I think is a good thing. Check out the Ladybird browser. They are 10% of the size of these other browsers in terms of code length, but getting up there in feature set. Very, very cool. You might ask, well, why have browsers been getting so large in the first place? And there are some theories. I'm not sure if they're correct, but they're fun to think about. And you think, well, why did we even get on that train? And other fun theories to think about. I would like to posit that this is an issue of ergonomics. People are trying to use the tools available to them in order to make their lives easier. One project that I think is really cool, alternative to React, is called Van.js, and they are kind of like a minimalist React-ish type thing, just fully JavaScript, no dependencies. It's pretty nice to use, pretty ergonomic. And look how small that is. It's tiny. Beautiful. Unfortunately, it is very slow. Just kidding. It's very fast. It kills everything on the benchmarks. I love projects like this. I think there's like millions of projects awaiting this if anybody's interested. Get the first 90% going, start a little movement. Whoa, I'm skipping that. Zig is another one of these. Zig is at like 550,000 lines, including standard library, and they're aiming to be a C replacement. Very cool language. Highly recommend checking it out. Another cool project, if you recognize all of these are like GNU core utils, normally coming in officially at 100,000 lines. Suckless is a project that has brought that, halved that. One nice feature about going smaller that people don't talk about is here's the GNU commit list for CP. You know, when you type in CP in the terminal, it's still getting commits. What is going on? This thing's been around. You'd think it's done. LS still getting commits. Echo still getting commits. You go over Suckless and nothing for since what is that? 2019. Nice and quiet. I do not like my dependencies changing all that much. It is hard to build things when the tools you're using themselves are not stable, right? How do you expect to make stable software with an unstable situation, you know? So a lot of developers, their solution is what I call drinking from the well. Let's go through a quick thought experiment. There's this wonderful little game, 200 megabytes, Baba Is You. I love this game, indie game. If you got gifted a Windows machine, how long would it take to get to playing Baba Is You? My guess is hours, right? You need to update, you need to install the NVIDIA drivers, and it's a whole thing. And like you compare that conceptually to like running Legend of Zelda on like a Wii, right? And it's a disc, and you put in the disc, and maybe it's like, I don't know, 90 seconds till you're playing. There's something wrong here. The way I like thinking about this is this dependency iceberg, right? Like you have this like pure code, and it's just all of this like implicit stuff that is being brought along, and it's like I see that, and then I'm like, oh, forget that. I'm just gonna write from scratch, and then I go to MDN, and I'm like overwhelmed by. I mean, they have frameworks for a reason. Sometimes these low-level APIs are pretty overwhelming. It's like drinking from a fire hose. And so I'm always faced with this dilemma of eating the iceberg or drinking from the fire hose. And sometimes other people, sometimes me, find this nice happy medium that I call drinking from the well. Drinking from well's not easy. Like you have to pull water vertically. This is not an easy task by any means, but it's better than the alternatives, right? And here's some examples that I think this guy, Bartos, he does these really beautiful 3D graphics educational guides online. And I was poking around, saw this comment, and apparently he just writes it in raw JavaScript and shaders. It's bananas, and it only comes. The watch guide is only like 7,000 lines of code, and it's actually beautiful code. It's not like it's really ugly. It's all completely readable, and it's just he drank from the well. And I kind of think that if he were to try to use 3JS or React, I don't think he would have been able to get the same fidelity and performance that he actually did. So sometimes I think like drinking from the well is the only solution. Another one's Rock, very cool language. It's kind of like a Haskell Elm type thing, but they're skipping all the normal steps of a programming language and going straight to like LLVM bytecode stuff. And so they're able to get really cool performance gains out of it and build to a lot of different platforms. Very, very cool project. Good podcast too. Richard Feldman is brilliant and does great interviews. And Zig, back to Zig. Rock is built on Zig partially, and Zig is built on CS++, but they moved off of it. They successfully found some. They were drinking from the well, but then they found some simpler primitives in WASM. And all of this is to replace C, like, so they use C to build something that's better than C, and now they're leaving C behind. They're gonna be better than C. This is the world I like to live in. So WASM. WASM is simple primitive. I think simple primitives are underrated, right? Like you can only build complex things out of simple things. Like it doesn't really work in the other direction. It's really hard to extract simplicity from complexity. Take like a great period of Giza. They just kind of stacked blocks, and for that amount of material, you can like actually make a cathedral. The only difference is like a few different materials methods and architecture, architecture. That's it's a paradigm shift, man. Alan Kay is famous for his research in this area. Very worthwhile. He was part of this group. Oh, look at that! Look at those pixels, man. What this says is the point of this project that he overtook in the early 2000s was to get all of computing in like about 20,000 lines of code, all the way from the hardware level down to like the user interface, and so many cool ideas came out of it. This is Ometa, made by my friend Alex Warth, and this was used to bootstrap a lot of these things. This is the let's see. Parser and compiler for Ometa to get Ometa code into JavaScript. That's all. That's the entire thing. And they used Ometa to make a graphics language, and this is like 300 lines of code that does all 2.5D graphics rendering that you would need. Anti-aliasing, a whole bunch of other stuff. The code is pretty cool. And so this is kind of like the weird architectures. They're using these small things and composing them to like bootstrap up, and so you end up with very simple concepts that push above their weight. And this is like a real stuff, right? Like this is an actual operating system that's in, I don't know, like 15 MB. It's like a JPEG. Do cool stuff with it. Oh yeah, and then they use that to make this 3D world. So he draws a 2D fish and it like swims off in 3D. It's bananas. Anyway, this paradigm is called T-shirt computing. You make these little programs, these like sub primitive layers that kind of like fit on a T-shirt. The whole idea is like small enough to like remember and fit in your head. Steps is over, the Alan Kay project, but I feel like that this is somewhat of a spiritual successor Dusk OS. Their whole thing is like, hey, if society collapses, we need to be able to like run computers and like compute and do stuff. So they're making an operating system that is very simple and can like run on any hardware. And it's right now about 20,000 lines of code. That number comes up again. The way they did it is they used Forth the old back-based language, and they used Forth to kind of bootstrap everything, use it as their simple primitive, and out of that, you get this thing called Uxin. Oh, it's so cool. These two cool people living on a sailboat, trying to save power, make this virtual machine very power efficient, and it's elegant and it can run on anything because of Dusk OS. And so people are writing these programs that will run on DS, Raspberry Pi, pretty much any hardware, and the programs they're making are like really cool. And they're portable and they're beautiful. I don't know. Look at that. Run on Nokia. This idea is not just for toys. This return to simple primitives is like really going mainstream. We are getting smaller instruction sets that hardware manufacturers and software, low-level software people can agree on. And I think this is good for everybody. I think people are really going to benefit from this very soon. And part of this is like, sometimes it's easy to forget that like you write this program that's like up in the ether and it like needs to run on like actual bits of silicon. Like there's an actual computer down there. One place this is evident is what is it? Array of structs and structs of arrays. When I first found this out, it blew my mind. But these are not equivalent. Like if you have like a whole like array of customers in JavaScript, that's going to be super slow. If you kind of do it a little bit more ugly and you like put them in arrays, pretty much anywhere it's going to be twice as fast iterating through them, or like manipulating them. It's just way easier for the like low-level L1 cache and L2 cache to manipulate them. Unintuitive. Doesn't feel good for humans, but the computers love it. It's hard to remember that we are slaves to the computers. Hacker News, big site, runs on a computer. I actually think it's 2 computers now, but it's like they spend like $200 a month in cloud costs, and that's like supporting millions and millions of active daily users. It's just like it's like a machine. When you respect the truth is the hardware. Cool things happen. It doesn't have to be the hardware though. SQLite, their truth is the file, and when you have that base truth, you get a lot of nice properties. You can send a database as a file, and the underlying disk can still work its magic because you're just doing a file. And SQLite is very small and has a pretty good feature parity. It's 10% of the size and punches above its weight, I think. I think JSON has possibly chosen a poor truth to obey. Characters, ASCII characters are probably not the right level. We might want to be sending bytes and not characters. When you start thinking about sending bytes, you get more types, you get way better compression, you get a whole bunch of very nice properties once you kind of scale down and you start thinking about bytes rather than ASCII characters. You can also go one step larger and start thinking about protocols themselves. Like the truth is the protocol, and you get weird things when you start thinking holistically here. You can do optimizations and literally perform computations before you get a response back. It's bananas. Look, the syntax for this looks a lot like protocol buffers because it's the same person. Same person wrote protocol buffers, developed this afterwards. So real cool stuff. I work on web, so a lot of the truth that I wrangle is in databases. And I was getting this is me working on a flashcard software. I got really frustrated that I was doing so many queries to the database, so I said, oh, I'm just going to do all the logic in the database. So this is a query that does, I don't know, a significant portion of what Anki does, or like flashcard software. Uh, Hard to see here, but you can find it on my blog. I think I call it like ugly SQL space repetition or something like that. My friend Derek Sivers saw this and sent me his implementation, which I thought was a lot cooler than mine. This is all of his Ruby code, the entire Ruby server. And the way it works is he creates some SQL functions, and then those are the sources of truth. And he iterates through those and then creates API routes for each of those. I found that to be lovely. He has a bigger implementation on his website. I highly recommend checking it out. And I've been trying to solve some of these problems myself with my programming language Scrap Script. My claim to fame is I have the programming language with the worst name known to man. Lots of different things that are lots of different fun little optimizations. Instead of sending the whole program, right, what we talked about earlier, you're sending bytes, you send a reference to the bytes. You send an address. There's a lot of inefficiencies happening that you can get around with content address. Yes? Excuse me? So the question is there any real movement in this direction? And let me think about this. Yeah, there are definite benefits. I think yeah, one thing that confuses me that I've been thinking a lot recently is if you could maybe package up some of these concepts, right? Small software, go over to Apple or Google. If you can convince them that they can get a 1% savings on either developer time or CPU costs, yeah, they would be very happy. They would pay a lot of money for that. So I I am confident that some of these ideas will be coming popular in the near future. Um, I don't know when. I know there is subcultures, as I showed you earlier, that are investigating this. But I don't know everything, right? I don't know what they're talking about. Uh, real quick, before more questions, I just wanted to uh, do some takeaways. Bad abstractions, they metastasize, kind of like a tumor, right? When you have these bad abstractions, they kind of grow, and you have to add more and more in order to, like, you felt this, right? You have this part of the code, and it has like its own gravitational field in your organization. Um, that's a sign. That's a sign of a bad abstraction. I think you guys all know that already. Um, nah, actually, I'm gonna skip it all. Let's do questions. What's up? Thank you. Hit me. So he's worried about in the pursuit of smallness, maybe making things less readable, and I totally agree that 100% happens. One way that I try to find that happy medium is there's only there's there's bugs that you understand and there's bugs that you don't understand. They're gonna happen either way, but it's like if you're in a small code base, at least like you can like potentially understand the problem. It's not just like some statistical anomaly that's happening somewhere. So like I don't know. It is a balance thing. I'm not trying to overthrow the government here. Mm-mm. Oh, oh, dang. Anything else? Oh, that's my blog. It's uh oh boy, yeah, it's a 50 it's 50-50. Like some of it's good, most of it's not, you know. Just did a whole thing on the history of microwave ovens. Just went down that rabbit hole. Uh, I do not work at IKEA. I'm not represented by IKEA. I'm just a mega fan. I love IKEA so much. They do amazing things. Oh my goodness. This is the best day of my life. I tried to get this many IKEA people at my wedding, and you guys didn't show up.
Usually in many projects, they always been like, just solve the problem, Rick. Don't think too much. Don't read too much around it. To me, though, I wanted to learn around the problem a lot, but it was just do the code. Don't think about it. Just do it. So, I mean, if you're gonna be like, if you're in a project and you want to do a small solution, so that the room complexity is small, they would be like, oh, don't do that. Just solve the problem. So, are you like super fast? So you
No,
doesn't
no, no.
show.
I am very not smart. Like what I'm trying to do is get the smart people to solve these problems. That's my goal. Because if you're just kind of if you're working your day job, I
Okay.
don't think you're going to be anybody's going to be solving these problems. It's going to be people working decades in order to find the right abstractions that give us a lift to make things a little bit better. But yeah, I don't know. It's not easy. We're definitely at a local maxima.
Okay, thank you.
All right. I think that is roughly it. 2 more minutes. One more question, maybe. No, everyone's groaning. Get out of here. Be gone.